Okay, so in the previous video, we saw that each reaction order has its own unique integrated rate law, which is really useful because from the integrated rate law, you can determine if a reaction is 0th order, 1st order, or 2nd order from experimental data. Okay, and what I'm showing here is just a quick summary of these rate laws and integrated rate laws for the different reaction orders. Note that all of the integrated rate laws adopt a form of y equals mx plus b, and the slope of all of the integrated rate laws are related to the rate constant. So for 0th order and 1st order, the slope of the line that comes out when plotting concentration or natural log of concentration versus time is the negative of the rate constant. For a 2nd order reaction, if you plot 1 divided by the concentration versus time, the slope is a positive value, and that is the rate constant. So what we're going to do in this video is take some experimental data and use these equations to figure out if a reaction is 0th order, 1st order, or 2nd order, and then also determine the rate constant. So I'm going to switching over to Excel here, and then once we're done with Excel, I'll also show you how to do this in Google Sheets. At least the graphing part of it, because it's a little bit different than this. Okay, so what I have here is some experimental data for the decomposition of N2O5. Okay, so we have the time here, which we're going to plot on the x-axis, and the concentration of N2O5, which is a reactant, as time proceeds. And we notice this concentration is decreasing as we would expect because N2O5 is being consumed when it decomposes. So if this is a 0th order reaction, we can plot this time versus concentration, and it should be a straight line if it's 0th order. So let's try this. So I selected the data here, and then if you're in Excel, go ahead and go up to Insert, and under Recommended Charts, I like to do the scatter. So pick this scatter right here. And what we see is that this line is absolutely curved and not linear, right? You can see that curvature. So this is not a 0th order reaction because this line is not linear. So I'm going to delete this graph because it's not 0th order. Okay, let's see if it's 1st order. So I'm going to copy the time data. So I'm hitting Control C here and copying that data, and Control V, so that's copy and paste. Okay, and then in this column, I want the natural log of the concentration of N2O5. Okay, so this is where Excel is really great because you can set up an equation for Excel to do this math for you. You click the equal sign, and that signals Excel this is an equation. So we want to do the natural log, so equal ln, and then open parenthesis, and I'm going to select the cell that contains the concentration of N2O5. And in my spreadsheet, that's cell E7. And when I close that parenthesis and click Enter, then it calculates the natural log of 0.1 for me. So the natural log of 0.1 is negative 2.306. Okay, I want to do that same thing for all of the other time points. But another really good benefit of Excel is I don't have to manually do it. I'm going to select this cell, and I'm going to put my cursor over the bottom right corner of this box, and you'll see the cursor changes into the crosshair. So when it's the crosshair, click and drag it down, and that will do the same calculation for all of the other times. And now we can plot this as a scatter plot. So select the data, click Insert, and plot a scatter. And what we see here is this does look pretty darn linear. So it's pretty likely that this is going to end up being a 1st order reaction. Okay, so we're going to keep this plot up, and just to make sure, we're going to plot and see if it's 2nd order. So for 2nd order, I'm going to copy the time data, and then I want to have 1 divided by the concentration of N2O5. Okay, so I need to calculate this. So I'm going to click equal, which signals Excel that this is going to be an equation. And I want to do 1 divided by the concentration of N2O5, which is cell E7 for me. When I do that, it takes 1 divided by 0.1, which has a value of 10. Now I'm going to do the same thing I did with natural log. I'm going to select that cell in the bottom right corner. I'm going to click and drag it down, and that's going to update all of the other cells so that they do 1 divided by concentration as well. Let's plot it. So we're going to select this data, insert, and select a scatter plot. Okay, so as you can see here, we definitely have curvature in this line. So this is not linear, so it's not second order. So indeed, we have determined that this reaction, the decomposition of N2O5, is first order because the natural log of concentration versus time is linear. So the last step would be to determine what the slope of this line is so that we can determine the rate constant. Okay, so I'm going to right click, or if you're a Mac user, control click on one of the points, and you'll have this add trend line option. Okay, when you do this, if you scroll down and select the display equation on chart option here, okay, then that's going, so that's telling the software to go ahead and put that equation right on your graph, which we've done here. Okay, so the slope of this line is negative 0.0069, and the y-intercept is negative 2.3026. So we remember from our integrated rate laws, right, that for a first order reaction, the slope is negative k, and our slope was negative 0.0069. So the rate constant for this reaction is 0.0069, and the unit would be 1 divided by second, because the time is in seconds, and a first order rate constant has the units of 1 divided by time. Okay, so let's see how you can plot this in Google Sheets if you don't have access to Microsoft Excel. So what I'm going to do here is I'm copying this data, equations and all, because you would do up to this point exactly the same way as we did in Excel. But I'm going to put it into a Google Sheet spreadsheet. Okay, so here we're looking at Google Sheets. Okay, I've done everything the same. What I want to do here is plot each of these, but in this case I know that I only need to plot the first order. So I'm going to select my data, choose Insert, Chart. Okay, so I want to change the chart type to a line. Okay, and then the last thing you want to do, right, so here you can very clearly see this is a straight line, and the last thing you want to do to get the y equals mx plus b equation is go to Customize, Series. Okay, you want to click Trend Line, and then scroll down and have the label Use Equation. When you do that, you see this new box pop up here, and this tells you y equals negative 6.92 times 10 to the minus third x plus negative 2.31. So the slope is negative 6.92 times 10 to the minus third. So the rate constant would be 6.92 times 10 to the minus third.